People often come to science with a simple request. They say, "Explain it to me." And that sounds reasonable. After all, explaining things is what science is supposed to do. But sometimes the request hides a deeper problem. Sometimes what people really mean is, "Explain it to me in terms of something I already understand." And that's where things get tricky, especially when we talk about magnets. Someone might ask, why do magnets attract each other? At first, this seems like a fair question. So we begin. We say magnets have poles, north and south, and opposite poles attract. But then the person says, yes, but why? So we go deeper. We talk about magnetic fields, invisible regions of influence that fill space. And again, they ask, why do fields exist? Now we're not explaining magnets anymore. We're explaining how the universe behaves. At some point, the explanation stops being familiar. We start talking about electrons, quantum rules, and mathematical descriptions of nature. And suddenly the listener is unhappy. They say, no, that's not an explanation. That's just words I don't understand. What they wanted was a story using ideas from everyday life, like ropes pulling or glue sticking. But magnets don't work like ropes. They don't work like glue. Nature doesn't care what feels comfortable to us. This is why we sometimes refuse to explain why magnets work. Not because we don't know anything, but because the question itself is flawed. Every explanation depends on something more basic. You can always ask why. One more time. Eventually, you hit the bottom. And at the bottom is not a simple picture, but a set of rules that nature follows. That's where science stops explaining why and starts describing how. The real mistake is thinking that understanding means reducing everything to familiar images. True understanding is recognizing that the universe is under no obligation to make sense in human terms. Magnets work because that is how the laws of nature are structured. We can describe those laws with incredible accuracy. We can predict what magnets will do, build machines with them, change the world with them. But demanding a deeper why beyond that is like asking why the rules of chess are the rules of chess. So when we refuse to explain why magnets work, we're not being mysterious or arrogant. We're being honest. We're saying this is where explanation ends and reality begins. And the beauty of science is not that it gives comforting answers, but that it shows us how strange, consistent, and wonderful the universe really is. Understanding doesn't come from forcing nature into simple stories. It comes from accepting nature on its own terms and being curious enough to keep learning, even when the answers don't feel simple anymore. When people ask for an explanation, they usually believe they are asking for knowledge. But very often what they are actually asking for is comfort. They want a new idea to be translated into something old and familiar, something they already understand. This desire is natural. Human beings learn by comparison. We understand new things by relating them to past experiences. But this habit, useful as it is, can quietly turn into a limitation. When we demand that everything be explained in familiar terms, we are no longer trying to understand nature. We are trying to force nature to behave like our everyday experiences. Consider how explanations usually unfold. A person asks a question that sounds simple, and the answer begins with a description. That feels reasonable, but as the explanation continues, it moves further away from ordinary life. The words become more technical, the ideas more abstract. At this point, the listener often becomes frustrated. They say the explanation is no good, not because it is wrong, but because it no longer fits inside their mental comfort zone. What they wanted was not a deeper understanding, but a familiar picture that feels satisfying. This is where a misunderstanding occurs. An explanation in science is not the same as a story. A story is judged by how relatable it is. A scientific explanation is judged by how accurately it describes reality and predicts behavior. These two goals are not always compatible. When someone insists that an explanation must be simple in a human everyday sense, they are quietly rejecting explanations that are closer to the truth. Nature does not organize itself around human intuition. It operates according to its own rules, whether those rules feel natural to us or not. Every time we explain something, we rely on ideas that we assume are already understood. We talk about forces, fields, particles, or energy as if they are solid foundations. But if someone insists on asking why again and again, those foundations begin to crumble. Why does a force exist? Why does a field behave the way it does? At some point, we reach ideas that cannot be reduced to simpler ones without losing accuracy. This is not a failure of science. It is a feature of knowledge itself. The mistake is believing that understanding means reducing everything to common sense. Common sense is built from a narrow slice of experience, slow speeds, moderate sizes, familiar materials. The universe is not limited to that slice. When science pushes beyond it, our intuition lags behind. Demanding that explanations stay within the boundaries of everyday experience is like demanding that a map of the world only include places we have personally visited. It may feel safer, but it is far less truthful. True understanding requires a different attitude. It requires the willingness to accept ideas that do not translate neatly into familiar images. It requires recognizing that explanation is a ladder, not a destination. Each rung stands on the one below it, and eventually the ladder ends. Not because we are lazy, but because there is nothing more basic to stand on. At that point, knowledge becomes a description of how the universe behaves, not a story about why it behaves that way. When people learn to let go of the need for comfort, something remarkable happens. Confusion turns into curiosity. Frustration turns into respect for the depth of reality. The goal of learning is no longer to feel satisfied, but to see more clearly. And in that clarity, even ideas that cannot be explained in familiar terms become meaningful, powerful, and deeply beautiful. Every explanation in science rests on something deeper, whether we notice it or not. When we explain a phenomenon, we usually begin from ideas that are already accepted, ideas that feel solid and unquestionable. But those ideas were once unexplained themselves. This is why explanation cannot continue forever. There is always a point where we stop asking for reasons and start accepting rules. That stopping point is not arbitrary. It is where our understanding of nature currently reaches its foundation. People often imagine that science should work like a chain, where each answer is neatly linked to the one before it, all the way back to some final self-evident truth. But knowledge does not work that way. It works more like a building. Each floor is supported by the one below it. You can ask what holds up the top floor, and the answer is the floor beneath. You can keep asking, but eventually you reach the ground. The ground does not rest on anything else. It simply is. Asking what holds up the ground misses the point of how buildings stand. When someone keeps asking why without realizing this, they are not being foolish, they are being human. Curiosity naturally pushes us to search for deeper reasons. But without recognizing that every explanation depends on assumptions, curiosity can turn into dissatisfaction. The person feels that no answer is ever complete. They assume that if only the explanation were better, simpler, or more intuitive, it would finally feel satisfying. In reality, the dissatisfaction comes from expecting something that explanation cannot provide. Scientific explanations are powerful not because they answer every why, but because they clearly state where the why questions stop and where the rules begin. These rules are not chosen for convenience. They are discovered through observation, experiment, and careful reasoning. We accept them not because they feel obvious, but because they work. They predict what will happen again and again with astonishing accuracy. It is important to understand that accepting a fundamental rule is not the same as giving up. On the contrary, it is an act of intellectual honesty. It means acknowledging the limits of reduction. When we say, this is how nature behaves, we are not closing the door on understanding. We are marking the deepest door we have opened so far. Beyond that door may lie deeper principles, but they will not come from endlessly rephrasing the same question. They will come from new observations, new experiments, and new ways of thinking. There is a quiet beauty in this structure of knowledge. It shows us that the universe is not built to satisfy human curiosity step by step, like a teacher patiently answering endless questions. Instead, it offers patterns. It offers consistency. It offers laws that, once learned, allow us to understand vast ranges of phenomena with a small set of ideas. That is not a weakness. It is one of the great strengths of science. When we accept that explanations have a foundation, we learn to ask better questions. Instead of demanding an impossible final why, we ask how far our understanding reaches and how it can be tested. We shift from frustration to exploration. We stop expecting certainty to feel familiar and start appreciating it for what it is, a reliable description of how the world behaves. In the end, understanding does not mean standing on an endless chain of reasons. It means standing firmly on the deepest ground we have found so far, aware that it may one day extend further. but content to use what we know to see the universe more clearly today. Human intuition is shaped by ordinary life. We grow up surrounded by objects we can touch, push, lift, and throw. We learn cause and effect through direct experience. Pull something and it moves, let go and it falls, press harder and it resists more. These experiences form a mental toolkit that feels reliable and universal. But that toolkit was never designed to understand how the deeper layers of nature behave. When we rely on it too heavily, it becomes an obstacle rather than a guide. When people try to understand unfamiliar phenomena, they instinctively reach for analogies. They compare new ideas to things they already know. This works well at first. Analogies act like bridges, allowing us to cross from the known to the unknown. But every analogy has limits. When pushed too far, it stops clarifying and starts misleading. The danger is not that analogies are used, but that they are trusted beyond their usefulness. In the case of phenomena that do not behave like everyday objects, familiar comparisons quickly fail. There is no tiny hand pulling things together, no invisible rope tying them up, no sticky substance making them cling. These images feel satisfying because they come from experience, but satisfaction is not a test of truth. The universe does not operate by borrowing mechanisms from human-scale life. It follows rules that exist independently of our expectations. When explanations abandon everyday imagery, people often say they are no longer explanations A. But this reaction confuses clarity with familiarity. An explanation can be precise, accurate, and powerful without being comforting. Mathematical descriptions, abstract concepts, and invisible interactions may feel distant, but they capture reality far better than simple stories ever could. Rejecting them because they feel strange is not a defense of understanding, it is a retreat from it. The challenge then is not to force complex ideas into simple metaphors, but to learn new ways of thinking. This requires patience and humility. It requires admitting that intuition is not a universal guide, but a local one, excellent for navigating everyday life, and unreliable beyond it. Once this is accepted, confusion becomes less threatening. Instead of asking why ideas do not fit intuition, we ask how intuition might be expanded or replaced. Science progresses by slowly retraining the mind. Concepts that once felt impossible gradually become familiar through use, not analogy. At first, they seem abstract and cold. Over time, as they are applied and tested, they gain meaning. They become tools rather than mysteries. The mind adapts, learning to think in ways it was never naturally equipped to do. There is a quiet discipline in accepting explanations that lack comforting images. It means trusting evidence over instinct. It means valuing consistency over relatability. This discipline opens the door to a deeper appreciation of reality, one that is not filtered through human convenience. The reward is not emotional satisfaction, but intellectual honesty. When we stop demanding that nature explain itself in familiar terms, something shifts. We no longer feel betrayed by strange answers. We begin to respect the universe for what it is, not for how closely it resembles our expectations. Understanding becomes an active process, not a passive one. It is something we build piece by piece by learning new languages of thought. In the end, the universe is not strange because it is poorly explained. It is strange because it is not built to match our instincts. Accepting this is not a loss. It is an invitation to grow beyond the limits of everyday intuition and to see reality with clearer, less comforting, but far more truthful eyes. Science is often misunderstood as a search for ultimate meaning, as if its purpose were to answer the deepest why questions humans can ask. But that expectation places a burden on science that it was never designed to carry. Science does not exist to tell us why the universe should exist or why its laws are the way they are. Its strength lies elsewhere. It tells us how things behave with precision, consistency, and astonishing reliability. Confusing this purpose leads to disappointment, not because science fails, but because it is being asked the wrong kind of question. When people hear a scientific explanation, they often listen for a final reason, something that feels like closure. They want an answer that sounds complete, in a philosophical sense. But scientific explanations do not end in comfort, they end in rules. These rules describe patterns observed in nature. They tell us what will happen if certain conditions are met. They allow us to predict outcomes, build technology, and test ideas against reality. That is not a small achievement. It is one of the most powerful ways of knowing ever developed. The trouble begins when someone asks for a reason beyond those rules. Why do these laws exist? Why not different ones? Why does the universe behave this way at all? These are meaningful questions, but they are not scientific ones. Science can tell us what happens if the laws were different, and it can explore how those laws relate to each other. What it cannot do is justify them in some ultimate sense. There is no deeper mechanism beneath every rule, waiting to be explained in simpler terms forever. This does not mean science is incomplete or shallow. It means it is honest about its limits. It does know. Invent answers where evidence cannot reach. Instead, it draws a clear line between description and speculation. On one side of that line is knowledge tested by experiment. On the other side are questions that belong to philosophy, metaphysics, or personal belief. Confusing these domains only creates frustration. There is a tendency to think that a description is inferior to a reason, but in science, a good description is extraordinarily rich. To describe how something behaves across all situations with no contradictions is to capture something deeply real about the universe. These descriptions are not arbitrary. They are constrained by observation, refined by experiment, and challenged relentlessly. When they survive, they earn our trust. The desire for ultimate reasons often comes from the way human language works. We are used to explanations involving intentions and purposes. We ask why someone did something, and the answer usually involves a goal or motive. But nature does not have intentions. It does not aim for outcomes. It follows patterns. Expecting it to offer reasons in human terms is a category mistake, like asking what a number wants or what a rock believes. Once this is understood, the role of science becomes clearer and more impressive. It is not a storyteller providing meaning, but a careful observer revealing structure. It replaces vague intuition with precise relationships. It turns mystery into reliable knowledge, even if that knowledge feels impersonal. And in doing so, it gives us a kind of understanding that is far more useful than comforting answers. Accepting that science explains how, not why, is not a loss of wonder. It is an invitation to a different kind of awe. The fact that a small set of rules can describe vast stretches of reality is remarkable. The fact that we can discover and use those rules at all is extraordinary. Understanding does not always come with a final reason attached. Sometimes it comes as clarity, consistency, and the quiet confidence that we are seeing the world as it truly behaves, not as we wish it to explain itself. When people repeatedly ask why, they often believe they are moving closer to truth. Each question feels like progress, as if peeling back layers will eventually reveal a final, satisfying answer. But this process has a hidden assumption, that reality is built in layers designed to match human curiosity. In practice, endless questioning does not always lead to deeper understanding. Sometimes it leads to a misunderstanding of what questions are capable of delivering. Asking why is powerful when it helps uncover causes within a system. Why did an object move? Because a force acted on it. Why did the force appear? Because certain conditions were present. These questions work as long as each answer points to something more fundamental that can be tested or observed. But eventually, the chain reaches a point where the answers no longer describe causes, but rules. At that moment, continuing to ask why does not sharpen understanding, it blurs it. At the foundation of scientific knowledge lie principles that are not explained by deeper causes within the same framework. They are starting points. These principles are not chosen because they feel intuitive or satisfying. They are chosen because they work. They consistently match what we observe in the world. They allow us to make predictions that can be checked, repeated, and trusted. This reliability is what gives them their authority. When someone refuses to accept these foundations and insists on a deeper why, they often mistake discomfort for incompleteness. The explanation feels unfinished, not because it is weak, but because it does not resolve into something familiar. The mind wants a final story, a reason that feels emotionally complete. But nature does not provide closure in that way. It provides patterns, not purposes. This is where confusion often arises. People assume that if a rule cannot be explained further, it must be arbitrary. In fact, it is the opposite. Fundamental rules are constrained more tightly than any explanation built on top of them. They survive countless tests. They resist contradiction. They unify many different phenomena under a single description. Their strength lies not in their depth of explanation, but in their breadth of application. Understanding this changes the way we approach questions. Instead of endlessly demanding reasons, We begin to ask how principles connect, how they can be tested, and how far they can be extended. We shift from chasing an unreachable final answer to exploring the structure that is already in front of us. This shift turns frustration into productivity. It replaces dissatisfaction with curiosity. There is also a kind of humility involved in accepting fundamental rules. It requires admitting that human curiosity, as powerful as it is, does not dictate the structure of reality. The universe does not owe us an explanation that feels complete in human terms. Our task is not to interrogate nature until it confesses a final reason, but to listen carefully to what it reveals through observation and experiment. When this attitude is adopted, the question why becomes more precise rather than more aggressive. We learn when to ask it and when to stop. We recognize that stopping is not surrender, but clarity. It marks the boundary between what can be explained within a system and what defines the system itself. In the end, the deepest understanding does not come from exhausting every why, but from knowing which why. Questions are meaningful. By respecting the limits of explanation, we gain a more accurate picture of reality. And in that accuracy, there is a quiet satisfaction. Not the satisfaction of a final answer, but the satisfaction of seeing how far understanding can truly go. Real understanding does not arrive all at once, and it does not arrive through memorization. It grows slowly through patience, repetition, and the willingness to sit with ideas that feel uncomfortable at first. Many people confuse understanding with familiarity. If an idea feels strange or unintuitive, they assume they have failed to grasp it. In truth, that feeling is often the first sign that learning has begun. When we encounter rules of nature that do not align with everyday experience, the natural reaction is resistance. We try to reshape them into something that fits our instincts. We look for metaphors that make them feel ordinary. While this can help at the beginning, it can also become a trap. If we refuse to move beyond intuition, we end up rejecting the very ideas that reveal how the universe actually works. The universe is not obligated to make sense in human terms. Our instincts evolved to help us survive at a certain scale, under certain conditions. They were not designed to understand invisible interactions, extreme speeds, or abstract relationships. When science exposes these deeper layers of reality, it challenges our intuition. Accepting this challenge is not a weakness. It is an essential step toward genuine understanding. True understanding requires humility. It means admitting that our natural ways of thinking are limited. It means trusting evidence even when it contradicts instinct. This does not mean abandoning intuition entirely, but recognizing its boundaries. Intuition can guide questions, but it cannot be the final judge of truth. When we allow evidence to take that role, our picture of reality becomes sharper and more reliable. There is also discipline involved in understanding. Learning unfamiliar concepts often feels slow and frustrating. Progress is not measured by how quickly an idea feels comfortable, but by how accurately it can be used. An idea that feels strange but consistently works is far more valuable than one that feels satisfying but fails under testing. Over time, as the strange idea proves itself again and again, it begins to feel natural. Understanding follows use, not the other way around. This process transforms the way we relate to knowledge. We stop expecting instant clarity and start valuing gradual insight. We accept that confusion is not an enemy, but a signal that the mind is being stretched. Instead of avoiding difficult ideas, we engage with them repeatedly, allowing understanding to form through experience. As understanding deepens, something interesting happens. Ideas that once felt abstract gain meaning. They become tools for thinking rather than obstacles to comprehension. We stop asking whether they feel right and start asking whether they work. This shift marks a transition from surface learning to genuine insight. Accepting nature on its own terms also brings a different kind of appreciation. We no longer demand that reality be comforting or intuitive. We respect it for its consistency, its precision, and its independence from human expectations. There is a quiet beauty in knowing that the universe operates by rules that are discoverable, even if they are not always easy to accept. In the end, real understanding is not about forcing the universe to make sense to us. It is about adjusting ourselves to the universe as it is. When we let go of the need for comfort and embrace the challenge of unfamiliar ideas, learning becomes deeper and more honest. And in that honesty, we find not confusion or frustration, but a clearer, more powerful way of seeing the world.